Okay, fantastic. So, as it was mentioned, hi everyone. I'm Michael. I'm from Antmicro, but also I'm the chair of outreach for Chips Alliance, and that's the hat I'm presenting in today. So yeah, we're calling it the open source hardware roadmap because we believe that Chips Alliance has a vital role to play in pushing that roadmap and making open source hardware happen. And we're going to tell you today a little bit about how we're going to do that, and welcome and encourage you to join us. So first up, who we are. I'm going to tell you a few words about our organization. Then I'm going to move to discuss a little bit about today's compute and design challenges. Stuff that we're trying to change and fix. And then I'm going to tell you about Chips Alliance projects, so things we're doing actively to change the status quo. Chips Alliance, we consider ourselves unique in the sense that, first up, of course, it's an organization that you can join, right? It's a Linux Foundation hosted organization that hosts companies and universities. And what we're doing as part of this effort is developing and hosting first open source hardware code and specs, right? So you could think open source CPUs, interconnect IP, or IO IP, or machine learning accelerators, all sorts of different things you might want to put into an ASIC or in an FPGA. So not just CPUs, not just cores, but actually extending the RISC-V mission into all sorts of both digital and analog, actually, IP. We have a very broad mission in that sense. We're looking at the entire landscape of hardware, predominantly the ASIC context, but also for FPGAs, and thinking how can we radically improve the status quo? How can we produce new specs and especially new code, new IB cores that people can easily reuse. This kind of combination of code and specs is really interesting because we're not one of those bodies that just kind of comes out and puts out a spec and hopes that people get right. We're actually, if we specify something, we also provide reference implementations and things you can immediately get started with. The second important thing to know about the Chips Alliance is our other area of activity, very dynamically developing, which is open source ASIC and FPGA development tools. And so it's not just the IP cores, it's not just the specifications, it's also the methodology. It's also the way people work with these things that we care about. And the fact that we kind of care about tools makes us pretty unique. We look at design methodologies, we look at verification, we look at simulation workflows for CI. There's different aspects of the tooling part, but all in all, we don't just care what is being done, we also care about how it's being done. And we want those things to be open source too. This is a big challenge, of course. It's a very wide array of things that we're handling, but we think that this kind of synergy combination of both like what you're doing and how you're doing it enables true innovation. So that's why we're kind of looking at both areas at the same time. Secondly, we're also an environment for collaboration, right? It's not just about what we do and the tools that we use, but it's also about the legal framework behind it, the governance, the standards. We think that we've, figured it out pretty well. We know how to collaborate on pretty hard and complex topics, right? Like AIB, like, different kinds of tools. We have created a framework that enables us to manage those projects effectively and govern them and make sure that they are sustainable, that we don't infringe patents, that we, generally speaking, produce things that are free from some kind of legal problems in the future. It's a long and tedious work to get there, but it's very useful to do that. And once you have that framework, you can do everything. And so we consider ourselves this barrier-free environment for collaboration, also in the legal sense, also in the formal and governance sense. But like just kind of looking at how people collaborate, we also like to speak about how we help people share resources. So forgetting about legal frameworks and governance and so on, we just help people collaborate more. We share the resources, we share code, we share practices, we share infrastructure, all of which can help to reduce the cost of hardware development. Because the ultimate challenge is, how do we make hardware more awesome without actually having everyone develop the same thing over and over again? And we're looking at this entire landscape as a collaborative opportunity, and the fact that many people have similar problems. For us, it's not like a competitive problem. For us, it's actually a nice problem to have, because we can pool those resources, we can pool the money, we can pool the code, and together we can achieve more. We have a lot of members. There's 16 companies at this point, of various size and kind. There are 5 key members: Alibaba, Sci5, Google, Intel, and Western Digital. These are the platinum members. They, of course, drive the activity of our board, but everyone's bringing in something. People have their own projects, their own ideas. So you're welcome to join. Of course, there's different levels, and naturally, you can join just as a silver member if you're a small organization. If you're a big fish and you want to really kind of shape the future of what open source hardware is going to look like, you can join as platinum. It's $25,000 actually to join as a platinum member. You also have to join the Linux Foundation, which depends on your size and some other circumstances. But in general, we're very happy to take in new members, and in fact, new members are signing up pretty rapidly. Of course, we have also universities and projects inside of CHIPS Alliance. There's 10 of them as far as I know, and basically we have some very, very interesting ones. We have Berkeley, of course. I mean, can you not have Berkeley, the creators of RISC-V? But we have also OpenRoad, which is a DARPA project for open source flows that I'm going to talk about later. We have the Technical University of Munich, which also is an extremely interesting organization. We have the RIAS Lab, which is doing a lot of great work in RISC-V software and other places. East San Diego, there's a lot of different universities, and we also encourage the universities to join us. We believe a lot of the innovation, a lot of the opportunities happening at universities and collaborating with companies to then take that open source work and make it practically useful is vital, and that's what we're encouraging. So kind of both sides, both those slides, both the company part and the university part, these are super important for us. So about the challenges that we're facing. First, of course, everyone's already noticed that hardware is getting more expensive to make, and that cost is just becoming unbearable. You have to be an extremely big organization to sustain that. How do we enable people to build these things in a more lean way? The other problem is related. So, a lot of the innovation that might happen is just stalled in some big corporate structures. So there's people that might innovate, but they just don't have a framework to innovate. They don't have the ability to convince the organizations and find the resources and fight the legal battles and so on. And then we also need things that are more purpose-built. We need to address different challenges in different ways, but at the same time, we can't afford to fragment. We can't afford everyone doing their own thing without any coordination. So how do we enable this innovation that crosses organizations, innovation that costs less, and innovation that gives you coordination without fragmentation? The answer is, of course, CHIPS Alliance. So we aim to deliver on several things. We want to just simply lower development costs for things, because if you have common IPs, if you have things you can just grab and start using, we're working on open source PCIe, open source DDR controllers. We're building open source interconnects. We have cores you can just grab. There's plenty of things that we're just developing for you to freely use. And of course, the other part with the tools and infrastructure, that's where we believe the true innovation is going to happen, because we believe design engineers being able to modify their tools is an extremely productive thing to do. And I'm going to show you how. I'm going to show you how we're already doing that, and how we think this is going to play out in the future. But generally speaking, we believe that the tools aspect is going to really revolutionize everything for hardware design. But of course, the common IP is also important, because if you're building something, having ready-made building blocks is just very good to have. So as I mentioned several times before, we're enabling this collaboration in hardware. So we've seen that in software. We've seen open source take over the world of software. How do we do that for hardware, and not just hardware as in RISC-V cores, which of course is super important, but in all of hardware? And we believe drawing upon a pool of broad experience and a wide array of different kinds of expertise, we can make this happen. We can make people collaborate between companies and universities, small groups. We believe that this combination of experiences coming from various angles is really, really important to achieve innovation, because sometimes it's non-trivial to understand what's going to be the next big thing. And secondly, yes, we need to keep this alignment. We need to keep compatibility when we're building things. So, for example, there's a lot of excitement and enthusiasm about accelerators for AI. How do we make so that even though everyone can develop their own AI accelerator as needed for their use case, all of this stays in some way compatible? All of this can be handled and thought about in a meaningful and easy to understand way, without causing fragmentation that comes with dozens of proprietary solutions competing and claiming that each of them is the best. So having some kind of an open source framework to work with these is probably the best idea. And generally speaking, we'll see with this lowering of costs and with this more collaborative model, we're going to see the Blue Hat business model play out itself. So basically, sorry, the idea of companies offering services around open source that help other people adopt what has been built and develop it into the direction that they want. And we also want to kind of develop a new model of promoting open source policies, of making people understand why open source is important, of helping governments and organizations understand that there is no going back. Like, hardware is going open source and we're making it happen. So now moving on to our projects, to give you a little bit of a more practical hint of what we're doing. And of course, this is just a subset. I'm not going to tell you about all the activity in Chips Alliance, because we have dozens of projects and lots and lots of things going on. But I'll try to give you an overview of a few things I believe is important to know. So first, that's important to know, we have work groups. There are 6 of them right now. I mean, there's some that are being spun up. It's not a fixed number, so like, don't treat this as the final number. But in general, we're looking at cores, interconnects, tools. The Rocket SoC actually has its own group because it's such a big development community, similar to Chisel. It's one of our kind of success stories, so it has its own group. We're spinning up, an acceleration group to help in that aspect. And of course, you can imagine in the future there's going to be more than that. We have some milestone achievements that we've delivered in 2020. We've started a major project that's focusing on SystemVerilog and in Verilator and in other free and open source tooling. We've developed several things like open source synthesis of SystemVerilog cores, open source linting and formatting, and CIs, parsers, for SystemVerilog. A lot of great work in the SystemVerilog domain. Then there's some key major projects we've been able to attract in 2020. We've kind of had Chisel join our forces. We had Open Road join us. We're collaborating very closely with Skywater. Overall, a lot of the open source innovation is flocking around Chips Alliance. We've released AIB and AIB 2.0, which is a chiplet specification from Intel. And this is a really exciting piece of news, because AIB is a really kind of state-of-the-art interconnect fabric that Intel's using in some real things. And we can also kind of have other people help develop and use this specification to deliver really fast interconnects in a chip. And we also have other great work in the interconnects area. such as the successful demonstration of OmniXtend, which is a memory-centric compute system. I'm going to tell you about more in a little bit. We've also delivered a new generation of SweRV cores. So SweRV is a family of cores coming from Western Digital originally, but now hosted by Chips Alliance. I'm going to tell you about that in a second too. So about Verilator and why it's important to us. Verilator is an open source simulation framework, but it's not just good because it's open source. It's good because it's good. It's good because it can outperform the so-called big three by a factor of even 11 times. This graph will show you how in different execution scenarios you'll see Verilator speed up extremely much, getting to up to as many as 7,000 cycles per second in simulation. So that makes it practical to actually run software in it. I mean, it's still a bit slow, but it is kind of usable. It's doable to boot Linux in Verilator. And the important thing about it is that it's open source, it's collaborative. We're actually collaborating with the maintainer of it, Wilson Snyder, and kind of expanding Verilator to cover new use cases to enable more SystemVerilog related scenarios. We're improving Verilator as such, trying to find ways to make it more applicable for verification. So plenty of things that we can do. And we believe that it's a great success story in itself, of course. Like, as you can see, Verilator has been in the making for over 20 years. But if you look at the graph of activity on the repository of things that are going on, it's speeding up. We've been kind of investing. We've been putting resources, and hopefully, of course, that trend continues. And we like to see those kind of little signs of change where people say, we support the big four simulators, and of course they include Verilator on the list. So kind of we're happy to see Verilator kind of join the big three to become the big four. And in fact, we believe that Verilator ultimately is the way to go. And there's plenty of course, innovation in simulation to do still, right? There's going to be many more exciting developments there. But we believe Verilator is a catalyst to all that development, because it's like the de facto standard open source solution in that area. It's really giving people great results at zero cost, right? It's basically completely free to use, completely scalable, and you can join and help us, develop faster. Our long-term vision for this is that we really believe that we can do all of it open source, including verification, not just simulation, open source synthesis in our scope, open source place and route. All of this eventually will enable this kind of scenario where you can use machine learning for the entire process without human interaction and without costly licenses, just like fully open source flows, and just go on and on and on and try to synthesize and place and route to design and do all those actions completely automatically to see what's the best result for your chip. We know it's an ambitious goal. That's why we're saying, it's a 7-year vision. But also we know that to have this result in 7 years, you have to start today. And the ones that will be working on this right now will be eventually the most successful and will see the most payout from being there early, from helping achieve this. And this entire flow being open source, it'll help us to customize everything as needed, and people will be able to collaborate on various levels of this stack. We really think that there's going to be a lot of disruption in this area. OpenRoad is one specific project that we're super excited about. It's a DARPA project that's aiming to just do completely no human in the loop, compiler for SOCs, also SIPs and PCBs, but we're kind of mostly talking about the SOCs part. They already have a fully automated flow. Of course, it still is a work in progress. There's a lot of things to do, but you can, feed it Verilog, get GDSII, and that's pretty fantastic. And already people have shown in this area that you're able to really achieve extraordinary results with open source and with machine learning. Google's been showing that with machine learning you can get on par results with humans. If you combine that with open source, if you combine that with deep optimization and customization for these kind of scenarios, we believe that we're going to achieve incredible results in the tooling aspect, which is of course kind of another place where we can innovate. It's not just about the process, the technology process, not just about the IP being optimized. It's also the tools. It's also the productivity that this is bringing. So OpenRoad is the perfect example of this. Another kind of accomplishment is with this SystemVerilog support and open source tooling. It's a collaboration between Google, Western Digital, and Antmicro, and of course others. We and Micro, we've been doing much of the work involved. We're kind of building. Google has released a SystemVerilog linter / formatter variable. We're kind of helping maintain that and develop it for new applications. SureLog is another framework that Google has helped open source. It's a parser, it's a fully blown parser for SystemVerilog, enabling things like eventually like UVM and all those kind of complex SystemVerilog scenarios. SureLog comes with what's called a universal hardware data model, so a way to represent SystemVerilog designs and also translate them to further frameworks like Yosys or Verilator. It's this kind of intermediate library, and we are expanding the UHDV support to Verilator and Yosys with great results, and kind of adding through this we'll be adding open source verification capabilities to Verilator. So overall, a lot of things happening in the SystemVerilog space, including a SystemVerilog test suite. We have a test suite that helps us track progress. You can see it online. This link will take you to the dashboard. We're testing individual features of the SystemVerilog standards, third-party test suites, select open source IP cores, SweRVM, ibex, and others. So we've kind of established a baseline. We've kind of tested open source tools for their support of SystemVerilog, and now we're improving that support. That's basically the whole point of SystemVerilog test suite. Take a look at what this landscape is today and see how you can improve it. Through this test suite, we've seen some incredible new things to emerge. There are parsers that we haven't yet heard before, but people that made them just came up front and said, hey guys, we have this parser that we didn't really promote very widely yet, but it's there. So this kind of test suite is actively expanded, and of course we're helping make it green. And Antmicro is behind this test suite together with Google, so we're actively pushing it forward. We've been able to achieve some really cool goals in the ibex core. The ibex core that is being used in OpenTitan project. This is actually being used in Open Hardware Group as well. Those activities, the linting, the formatting, the synthesis that we can now perform fully open source, enable us some really interesting CI flows. People can more actively collaborate and see that their code conforms to a standard. Low Risk, the group behind OpenTitan, actually has this kind of style guide that they follow, and other people are adopting this style guide, and we're helping to follow that style guide. We have rules for linting that will show you how you diverge. This is a great collaboration between Low Risk, Google, Western Digital, and Micro. And we're really hopeful for some great results there. We've been able to synthesize the ibex core and Yosys, which has kind of generated a lot of enthusiasm because it's the first step on like automating a fully open source flow. We can actually also run ibex in open source FPGA tooling. I don't have it on the slide here, but like Chiplet Alliance is also kind of supporting and actively developing, open source FPGA tooling. So that is kind of enabling people to run the entire flow in FPGA without having to rely on any proprietary tool whatsoever. And that's, again, a catalyst for innovation. AAB is something I've mentioned already. It's an incredible development. It's a very fast interconnect that's it's optimized for low power and high bandwidth. And it's of course developed by Intel, but it's meant to be portable and usable on various silicon architectures. And you can build various protocols like AXI on top of AIB. So we have a spec, we have a really good implementation. There's AIB 2.0 now. with double I/O density, double the data rate, and lower I/O voltage. All of these are kind of very good things to have, and it's a really great state-of-the-art IP that you can just grab from GitHub and start using in your chips. And you also have a spec that clearly describes what it does. So like this co-development of spec and code is really, really good. And AIB is generating a lot of enthusiasm. And it's also kind of luring many persons to join, or many companies to join us. OmniXtend is another interconnect piece of work that we're doing. This is driven heavily by Western Digital, but also others. And there's a network fabric that connects, various kinds of accelerators. And there's a memory fabric that is actually the central part of the architecture. So it's not that like there's a CPU driving this specific processing platform. In OmniXtend, you're thinking, this is the memory, this is the data. This is the data I'm going to process. And all those processing methods using some kind of a CPU or GPU or FPGA or an ASIC accelerator, all of this is kind of done. They're kind of peers, right? You can use various compute resources to process the data in your memory, and the memory is central. And we've actually been able to, demonstrate how OmniXtend can work in practice, connecting two quad-core CPUs into one interconnected device. And as you can see, we're seeing 8 physical cores, even though those reside onto different devices. Just they're connected with FinoSwitch with OmniXtend between them. And this is showing how you can build distributed systems that are kind of physically residing in different places, but they're all cache coherent, they're all visible as part of one system. And this is, of course, going to enable some really cool innovation, because you can break down your compute device into multiple devices and just interface over OmniXtend. It's really, really cool. As I've mentioned, there's been a lot of progress in the SweRVM Core Roadmap. That we have the SweRVM EH2 and EL2. The EH2 is actually a dual-threaded core. It's a really interesting option for a very small but powerful RISC-V. It's been open source. It's being developed, and also it has this smaller brother, the EL2, which is much smaller but kind of also quite performant. It's been kind of tested. It's being deployed in real products by Western Digital. So overall, I encourage you to look at SweRV. It's a SystemVerilog core as well. So of course, all the SystemVerilog work is useful for SweRV too. And in the future, as you can see, there's going to be some even more interesting additions to that family. So please kind of follow it closely. One of the last things I'm going to talk about is the open source EDA tools ecosystem around Chisel. So Chisel is a programming language, as you know, for hardware. And the goal of it is coming from Berkeley and the RISC-V ecosystem. The goal of Chisel is to kind of avoid having to do low-level RTL if you can avoid it. So of course you have to program hardware, but you're thinking, how can I make my work easier? How can I just write code that's more productive? And it uses Scala as a base. And thanks to this, it's able to create some abstractions that help people be more productive. And through this abstraction level, it also enables new methodologies of working. The Chisel community has FireSim, which is a very fast, simulator for FPGAs for Chisel. It has tools like Chipyard, which helps people accumulate different kinds of IPs into a single design, into an SoC. There's a lot of utilities, there's a lot of tools in this ecosystem. Chisel is not just a programming language, it is a framework, and it's been fully donated into the CHIPS Alliance. It's been fully integrated into our organization. So it's pretty exciting to have them on board. It's pretty exciting to have Berkeley and Sci-Fi and others on board with Rocket Chip and everything. So the Chisel ecosystem is very vibrant. It's a great success story, and we're very happy to have them on board. That's basically the end of my presentation. I hope I've encouraged you to join our alliance. You can share things with other people, both in terms of digital and analog IP. I haven't, of course, mentioned some of these things, but we do have work in the analog space as well. You can collaborate in tools. You can share good practices, and generally speaking, you can even just if you're not ready to collaborate and contribute, it's still kind of a place where you can get stuff and start using stuff. And that's pretty complex IP blocks. That's, you know, advanced cores. That's high quality designs. These are not toys. These are actual production grade systems. And you can just join Chips Alliance to show that you're a forward thinking organization, that that you can collaborate with all those members that are looking at open source hardware and thinking how to innovate. If you join us, you're going to be able to be exposed to all these people that care about open source hardware and care about innovation and hardware. You don't have to join to just participate, right? You can actually go to GitHub and contribute today. So this is not a barrier. But like, if you really want to be involved, if you really want to be having those conversations on a week-to-week basis, you know, the best way to do that is to join Chips Alliance and help us develop the open source hardware landscape. Thank you very much. That's the link.
Hi, Michael. Thank you for a good, impressive presentation. So, Chip Alliance includes many various effective technology and methodology. So, we expect the Chip Alliance to join and good success. So, I checked the question from the audience right now, so no question. So, if I have one question, so just the impression. So, do you have some? Sorry. Sorry. How do you feel difference between university and companies who is approaching the Chip Alliance? Just impression, please. Do you have some?
Sorry. So I'll answer your question, right, with universities versus companies. We encourage and welcome everyone. It's a bit easier, of course, for the universities because it's mostly the legal paperwork, but the cost is kind of not that big. But we think both are very, very important, right? Like, without universities, we wouldn't have this research arm that's pushing things forward into the future. Without companies, we wouldn't have this practical approach of how do you actually use what's being developed. But it's actually easy to join either way. Like, basically, the cost for companies is fairly small. The cost for universities, as far as I remember, is kind of negligible. So if you're a forward-thinking university from any part of the world, you can see at Rios Labs, for example, that also joined Chips Alliance. We encourage you to join because we believe a lot of the innovation is happening at universities. You could see what happened with RISC-V itself, right? Like, it came from Berkeley. It eventually, of course, spun out into a company, Sci5, but like, the original innovation is coming from a leading university, and we believe there's more success stories like this in the future, and you could be part of it. We think that, but you don't have to reinvent the wheel. So Chips Alliance will give you this legal framework, this community that you need to grow your system. RISC-V had to do it on its own, right? It had to achieve this because RISC-V didn't exist before RISC-V. So Sci5 and Berkeley, they had to create the RISC-V International to make this happen. But going forward, we believe that if you have a similar gem, you know, like some incredible technology that you want to take out into the world and make it used and grow a community around it, you can just do it as part of Chips Alliance. You don't have to start a Chisel Foundation or a SweRVM Foundation. Yeah. You can just do it as a group in Chips Alliance.
Okay. Thank you for good answer the presentation. So sorry for just stopping it, but it's a timing over. So thank you so much for presentation. Yep. So yeah. So
thank you very much. I appreciate being invited.
Okay.